अच्छा जी, तो इलेक्ट्रिक फील्ड के अंदर जो टॉपिक हम बेटा पढ़ रहे हैं ना, दैट इज इलेक्ट्रिक फील्ड, राइट। और इलेक्ट्रिक फील्ड में जो टॉपिक्स हम अभी तक पढ़ चुके हैं ना, जो लोग नहीं आए थे, इलेक्ट्रिक फील्ड टाइप्स, इलेक्ट्रिक फील्ड ऑफ कोर्स बेसिक इंट्रोडक्शन, इलेक्ट्रिक फील्ड टाइप्स, इलेक्ट्रिक फील्ड स्ट्रेंथ which is force per unit charge, or difference in potential per unit plate separation if the field is uniform, parallel plates, तो पैरेलल प्लेट्स के बीच में पोटेंशियल डिफरेंस कितना है, पैरेलल प्लेट्स के बीच में सेपरेशन कितनी है, दैट इज डी. So these are two formulas to calculate electric field strength. This is the general formula which you can use in every situation. This is the specific formula only for uniform electric field strength. ठीक है. Then we studied motion of charges in uniform electric field. We have spent almost 7-8 days on these topics. उसके बाद एंड द थिंग इज कि इसकी भी वीडियो रिकॉर्डेड है, वो अभी मैंने उस पर डाल दी है यूट्यूब पे, वो फिर उसका लिंक शेयर करूंगा तो वहां से आप इसको देख लोगे. अच्छा, उसके बाद कूलम्स लॉ वाज द लास्ट टॉपिक. कूलम्स लॉ प्रोवाइड यू द क्वांटिटेटिव मेजर ऑफ मेजरिंग द repulsive or attractive force between two charges. If two charges are there and they are repelling each other or attracting each other, तो भाई वो कितनी फोर्स से अट्रैक्ट या रिपेल कर रहे हैं, अगर आपने वो फोर्स मेजर करनी है तो यू विल बी यूजिंग कूलम्स लॉ. जिस तरह इन ग्रेविटेशनल फील्ड इट वाज न्यूटन्स यूनिवर्सल लॉ दैट यू यूज टू मेजर द ग्रेविटेशनल फोर्स बिटवीन टू मैसेस. वो क्या था, F इक्वल्स G, कैपिटल G, M1 M2 over R square. So similar way, if two charges are there and they are repelling or attracting and you have to find that force, so Coulomb's law will be used. So this is the constant 1 over 4 pi epsilon naught, and 1 over 4 pi epsilon naught is also equal to K. ठीक है, this is the constant and its value is given in the data booklet. Like G की वैल्यू क्या होती है, 6.67 into 10 to the power minus 11. इसी तरह K की वैल्यू या 1 over 4 pi epsilon naught की वैल्यू गिवन होती है, that is 8.99 into 10 to the power 9. Q is first charge, small q is second charge, and R square, R is the separation between center of charges. ठीक है? Okay. So today's topic we have to focus on two things. One, Coulomb's law calculation, and second, electric field strength. We have already studied electric field strength, लेकिन यहाँ पे this is the different version of same electric field strength. So first of all, let's look for the calculation of Coulomb's law. अच्छा बेटा, as I told you कि Coulomb's law provides you a quantitative measure of the attractive or repulsive force between the charges. So we say it's quantitative measure of electric force between charges. अच्छा, then the next thing is, let's say कि if this is plus Q and this is another charge plus Q, so of course they are both are positive, so they are repelling each other with a force F. अच्छा, this force F will have the same magnitude regardless of size of charges, because this is Newton's third law. Every action is having equal but oppositely directed reaction. So no matter कि which charge is bigger or smaller, they will be experiencing same amount of force. अच्छा, उसके बाद ये था कि we have to look for the distance between their charges. अगर ये r distance है तो हम क्या करेंगे, we will be using this equation. F is K Q over R square, and using this you can find the electric force between the charges. Okay, let's look for one example. अच्छा, example is के let's say inside an atom or nucleus, this is nucleus, there are two protons, so these are two protons. अच्छा, अब these are the protons, so what you have to do is you have to find a force between them. So let's say find electric force between protons over gravitational force between protons. So this is the ratio, actually you have to find this force ratio. So electric force between the protons over gravitational force between the protons, and let's say no other data is being provided. ठीक है? So the thing is protons. So first thing is, as these are protons, so you already know something about it from the data sheet. और वो आपको क्या पता है, प्रोटॉन का चार्ज पता है एंड प्रोटॉन का मास. द चार्ज ऑफ प्रोटॉन इज 1.6 into 10 power minus 19 and mass is 1.66 into 10 power minus 27 kg. सो ये दो चीजें जो है यू नो इट फ्रॉम द डाटा शीट. उसके बाद यू विल सी कि और क्या आपको गिवन है. जी, G and K, these are again the data sheet values. So value of G is 6.67 into 10 to the power minus 11 and value of K is 8.99 into 10 to the power 9. So everything is coming from the data sheet, page number 2. ठीक है. अब what you will do is you just will put the formula over there and put the values to solve it, right? Only one thing is there, the missing thing. What is the missing thing that you want to know? And that is distance or r. R is missing. Like capital Q is first charge, small q is second charge. ठीक है. So as both are protons, so Q1 Q2 दोनों protons होंगे. Okay. So the thing is, the missing quantities are, you don't know how much is the distance between them. अच्छा, when something is missing ना, तो वो deliberately missing होता है. अब उसका advantage क्या होता है R का? अगर R missing है तो इसका मतलब है this has to be cancelled away, क्योंकि उसने नहीं बताया, आपको भी नहीं पता, ठीक है, कि ये कितना R है, प्रोटॉन्स के बीच में कितना डिस्टेंस है, वी डोंट नो अबाउट दैट, राइट. सो दैट्स व्हाई ऐसी चीज जो है वो कैंसिलेशन टर्म कहलाती है, कैंसिलेशन टर्म. लाइक व्हेन एज यू आर यूजिंग टू फॉर्मूलाज, so definitely there will be a way कि this R has to be cancelled away. जब दो फॉर्मूले यूज करते हैं तो उसमें कोई चीज कैंसिल हो सकती है आपस में. अगर एक फॉर्मूला यूज करें तो उसमें कैंसिल नहीं हो सकती. अगर मैं सिंपल ये कहूं कि फाइंड ओनली द इलेक्ट्रिक फोर्स बिटवीन द प्रोटॉन्स, तो अब आर आपको पता होना चाहिए. अब आर आप कैंसिल नहीं कर सकते बिकॉज यू ओनली हैव टू फाइंड वन थिंग विच इज दिस फोर्स. सो यू हैव टू नो द वैल्यू फॉर आर. लेकिन when you have to find two things, so maybe if one quantity is not given, so that quantity is going to be cancelled away, right? So अभी try to solve this. आप लोग खुद ट्राई करें सॉल्व करने की. चलें, ट्राई टू सॉल्व इट बेटा. अच्छा देखिए यार, आपने यू जस्ट हैव टू राइट द फॉर्मूला ना. इलेक्ट्रिक फोर्स के क्यू क्यू ओवर आर स्क्वायर, ग्रेविटेशनल फोर्स जी एम एम ओवर आर स्क्वायर इज कैंसल्ड अवे बिकॉज दिस वाज द डिस्टेंस बिटवीन द प्रोटॉन्स. So as the distance is same for both forces, so cancelled away, so you are left with this term. And as all these 6 quantities are given over here, so you will just put their value. Remember one thing, okay, as the charge of proton is coming 2 times, so you have to take its square. Don't multiply it with 2, right? A common mistake, you do it like this, 1.6 into 10 raised power minus 19. So this is wrong. आप कहते हैं 2 charges हैं, तो भाई दोनों चार्जेस को अलग अलग लिखना है. तो फिर जब एक चीज रिपीट हो रही है लाइक x इंटू एक्स, तो वो x स्क्वायर होगा, 2x नहीं होगा, x स्क्वायर होगा. दैट्स व्हाई यू हैव टू टेक इट स्क्वायर ओवर देयर. दिस इज वन कॉमन मिस्टेक, ठीक है. और इसी तरह यू डू द सेम विद द मास. ठीक है, मे बी. हाँ, 1.25 into 10 power 36. So 1.25 into 10 power 36. ठीक है. So this is electric force over gravitational force. So it means that actually this is ratio 1. It means that electric force is far way stronger than the gravitational force. ठीक है. Why? Because you can see कि भाई इसका आंसर जो है, आंसर ऑफ दिस रेशियो इज टू मच, 10 raised power 36. ठीक है. तो इलेक्ट्रिक फोर्स इज वे स्ट्रॉन्गर. एंड व्हाट इज द रीजन फॉर दैट? द रीजन इज दिस. You can see कि G value is minus 11 while K value is 10 raised power plus 9. So the only reason is constant. The electric constant value is too much than the gravitational field constant. So that's why electric force is a stronger force. ठीक है. So these two protons are pushing each other with very strong force. तो फिर ये न्यूक्लियस के अंदर कैसे हैं? स्टिल दे आर इनसाइड न्यूक्लियस. एएस में पढ़ा था, न्यूक्लियर बाइंडिंग फोर्स, strong nuclear force, strong nuclear force. So we say there exists a strong nuclear force between them, strong nuclear force. ठीक है, so this strong nuclear force जो है will be there. अच्छा जी, so this is done. Electric force is very stronger than gravitational force. So how protons can still be inside nucleus? Because of very strong nuclear force inside the nucleus, which is a short range force. अच्छा, let's go to the next topic, which is electric field strength. अच्छा, we have discussed something about electric field strength, like its definition. Electric field strength is electric force acting per unit charge, and then its unit is Newton per coulomb. Based on this, force over charge, Newton per coulomb. It is vector quantity, and its direction is same as direction of force on a test positive charge. This is very important. This year, अभी few days ago, ये इसका पेपर हुआ है, और उसमें उसने ये क्वेश्चन पूछा है कि भाई इलेक्ट्रिक फील्ड स्ट्रेंथ जो है उसकी इलेक्ट्रिक फील्ड स्ट्रेंथ की डायरेक्शन क्या है? सिंपल चार्ज था और उसकी ई की डायरेक्शन देखनी थी. ओके, तो अब बेटा इसका नेक्स्ट वर्जन इसका देखते हैं, द इलेक्ट्रिक फील्ड स्ट्रेंथ इन टर्म्स ऑफ कूलम्स लॉ. नाउ सो वी से इलेक्ट्रिक फील्ड स्ट्रेंथ इन टर्म्स ऑफ कूलम्स लॉ. ओके बेटा, सो देखो, लेट्स से इफ दिस इज अ पॉजिटिव क्यू चार्ज and then this is a point P at which you have to find its electric field strength. Just imagine like gravitational field strength, na? Okay, this is Earth and this is a point above the surface of Earth where you have to find its gravitational field strength. So we know that as we move away from Earth, so what happened to gravitational field strength? Its value decreases. ऐसे ही है ना? Similar thing is going to happen here, that as we move away from a positive charge, its electric field strength decreases. So you can imagine this as Earth. ठीक है, और ग्रेविटेशनल फील्ड स्ट्रेंथ सेम एज इलेक्ट्रिक फील्ड स्ट्रेंथ सेम एज ग्रेविटेशनल फील्ड स्ट्रेंथ. ओके, सो व्हाट यू विल डू इज, the objective is that due to this positive charge you have to find its electric field strength at this point. What we are going to do, we are going to place a test positive charge at that point. ठीक है, first step, place a test positive charge at that point. अच्छा, what's going to happen is that this charge is going to experience a repulsive force. ऐसे ही है ना? So a repulsive force will be acting on this, a repulsive force F. अच्छा, we know the distance from center of that charge to this point, and that distance is R. This distance is R. And this small q is going to experience a repulsive force because both are similar charges. Now, how we can find the value of this force? Coulomb's law. Use Coulomb's law. So that is K Q over R square, distance between them. So this is the electric force that this small test charge is experiencing because of the large charge. Now what you're going to do is, we know that E is equal to F over Q. So what you will do is, you will simply put the value of this F over there. कि भाई ये जो F की वैल्यू है ना, आप इस वैल्यू को यहाँ पे इसकी जगह इंसर्ट कर दो. ठीक है, so what's going to happen is, this is Q over R square, and then divide it with small q. Right? So what will happen is that these two small q's are going to be cancelled away. So you are left with KQ over R square. KQ over R square. So it means that this electric field strength is equal to KQ over R square. So this is our final answer. KQ over R square. We can write this in another format as well. You know that K is equal to 1 over 4 pi epsilon naught. So at place of K, we can write 1 over 4 pi epsilon naught, and then this Q over R square will remain over there. So this is another format of the same equation. One more thing, as you know that gravitational field strength was negative all the time. It was like G is negative gm over r square. Why it was negative? Why it was negative? Because gravitational force is only attractive. Like gravity never repel anything. Gravity means attraction. I'll explain this. Acha, so we know that this, why this negative sign is there, because since gravitational force is attractive, ठीक है, gravitational force is only attractive and that is represented with this negative sign. If a force is attractive only, so we put a negative sign over there. Acha, what will happen to this? This force can be repulsive, it can be attractive as well. Let's say if we replace this charge with the negative q, so what will happen now? The direction of force is going to change. First it was that way, now it will this way. जाहिर है ये चार्ज अट्रैक्ट होना शुरू हो जाएगा ना. तो जब ये चार्ज अट्रैक्ट होगा तो इसका मतलब क्या है कि ये फोर्स इस तरफ होएगी, तो जिस तरफ फोर्स है उसी तरफ इलेक्ट्रिक फील्ड स्ट्रेंथ है, तो इलेक्ट्रिक फील्ड स्ट्रेंथ की डायरेक्शन भी चेंज हो जाएगी. इट मींस कि ये जो इलेक्ट्रिक फील्ड स्ट्रेंथ है, दिस कैन बी पॉजिटिव और नेगेटिव, but it depends on the charge. If central charge is positive, electric field strength is positive. If central charge is negative, electric field strength is negative. So this is one difference. Gravitational field strength is always negative. We say this is always negative because we have to compare them as well. Later in this chapter they will ask us to compare gravitational force and electric force, gravitational field strength and electric field strength. So we should know this. It's always attractive, while electric field strength can be positive or negative. Always attractive mean always negative or always attractive. So this can be positive or negative depending on this charge at the center. Okay? So this is first thing. Now I have to tell you what is this epsilon naught. I have explained that in previous class कि ये epsilon naught क्या है, लेकिन let me tell you again about this. अच्छा देखो बेटा, this is k equal 1 over 4 pi epsilon naught. What question is, what is epsilon naught? Epsilon naught. This is its pronunciation, but its name, not the name, but pronunciation. Its name is permittivity of medium. ठीक है, इसका नाम है permittivity of the medium, right? और इसकी जो वैल्यू है वो 8.5 into 8.55 into 10 power minus 12 होती है, and this value is given in the data sheet. Given in data sheet. अब ये है क्या? The question is, what is it and what is its significance? So its significance is, let's say, okay, you want to apply some force on any other thing. Let's say you want to apply a force on the wall, right? So if there is nothing between your hand and the wall and you apply the force, so your force would be in bigger amount. ऐसे ही है ना? ठीक है? तो maybe it will hurt you more अगर if you are punching the wall, so it will hurt you more. Why? Because there is nothing between you and wall. But if I place a cushion over there or some foam or cushion over there, and if I punch it now, so what's going to happen now? If the foam is there or a cushion is there and you are punching the wall, actually you are punching the cushion, right? So what will happen to your force? Will your force remain the same acting on the wall, or it will decrease? It will decrease. Why it decreases? Because of the cushion. So epsilon naught is actually the cushion between the charges. Let's say if two charges are there and between them is air or vacuum, then nothing is there that can prevent this force. But if there is some other medium like insulator, glass, water, any other thing is there between the two charges, then that medium is going to affect the force between these charges, right? So epsilon naught or permittivity of the medium is the constant of the medium between the charges that is going to affect the value of force between the two charges. ठीक है. And for air and vacuum, if there is air or vacuum between the charges, then the value is constant, epsilon naught. And when you put this value over there, 1 over 4 pi into epsilon naught, so you will get an answer of 8.99 into 10 raised to power 9. So this is also given in the data booklet, and this is also given in the data booklet. So whenever k will be there, you can write it 1 over 4 pi epsilon naught, or if 1 over 4 pi epsilon naught it, you can write k at that place as well. Okay, is it clear? Okay, so right, where were we? We were at electric field strength expression. So let's move on. So this is our third formula for electric field strength. First formula was electric force per unit charge. Second formula was for uniform field. And now the third formula is plus minus k q over r square, or plus minus q over 4 pi epsilon naught r square. So three formulas. The first formula is defining equation, like you define it. Electric field strength is electric force acting per unit charge. Second is for uniform electric field, parallel plates. So this is for uniform electric field. The third is in terms of Coulomb's law. In terms of Coulomb's law. Okay, now we have to do some graphical analysis of this. Graphical analysis of E. Graphical analysis means that we want to examine the changes in electric field strength due to a charge if we change the distance from it. Let's say this is the charge, and first you are at this point at the surface and you want to know how much is the electric field strength, and then you are moving away. So you have to see and observe how electric field strength will change if you move away from the charge. So for this we know that E is k q over r square. अच्छा, इमेजिन के आपके पास एक पॉजिटिव चार्ज यहाँ पर है जिसकी वजह से आपने इलेक्ट्रिक फील्ड स्ट्रेंथ निकालनी है. दिस इज पॉइंट 1 एट द सरफेस, पॉइंट 2, पॉइंट 3, पॉइंट 4 एंड पॉइंट 5. तो इन 5 पॉइंट्स के ऊपर आपने क्या करना है, इलेक्ट्रिक फील्ड स्ट्रेंथ जो है वो फाइंड करनी है और उसका ग्राफ बनाना है आपने. सो ओके, we will say कि भाई at all these 5 points the value of k and q will remain constant, it's not going to change. So we say E is equal to constant over r square, because this is constant, k q is not going to change. The only thing that is going to change is r and E. R is independent variable and E is dependent variable. You will change r and E will change as a result. So this is independent. This we will study in paper 5 as well. Same thing कि भाई इंडिपेंडेंट क्या है, डिपेंडेंट क्या है. सो दिस E is dependent. So it shows that E will be inversely proportional to R square. Right? This is the expression now. So now we figured out a relation between them, between E and R. So let me just quickly sketch a schematic graph, a general graph, and then in next class we will try to draw the measured graph. So you know, when these are inversely proportional, if you increase R 2 times, then E will be decreasing 4 times because of the square. If you increase R 3 times, E is going to decrease by 9 times because of its square. Okay? Similarly, if you increase R 4 times, E is going to decrease 16 times. So it means that this is going to be an exponential curve, not the linear curve. Linear curve happens if R square is not there. So you increase R 2 times, so E decreases 2 times, increase R 3 times, this decreases 3 times. But as it is square, तो इसलिए बेटा स्क्वायर ग्राफ हमेशा एक्सपोनेंशियल ग्राफ बनता है, कर्व ग्राफ बनता है. ठीक है. सो बेटा इसका जो कर्व ग्राफ बनेगा वो कुछ स्कीमेटिक ग्राफ ऐसे बनेगा, और इसी तरह यहां से यूं बनेगा. अब व्हाई आई हैव ड्रॉन 2 लाइंस. द फर्स्ट लाइन इज if the central charge is positive, then all the electric field strength would be positive. So this graph will be drawn. But if the central charge is negative like this, positive to positive hoga, but if the central charge Q is negative, then E would have negative values. So that's why this graph would be for negative Q, right?